Welcome to this episode of Let's Be Civil. On this episode of Let's Be Civil, I'm speaking with Brian Barnett. Brian is a civil engineering graduate from the University of Texas at Austin. He has been practicing structural engineering for nearly 35 years. He is currently a principal engineer at Pickett and Associates. Brian's work focuses on the electrical utility industry and the design of high voltage transmission lines. Okay, everybody, welcome back to another edition of the podcast, Let's Be Civil. And you know, we go far and wide for our guests. And today, Brian is with us, and you can see he's wearing the corporate logo. I think you have to sit up a little bit higher there. So there you go. Now we can see the corporate. Make sure we get, so this is the NASCAR version of Let's Be Civil. As we do with our podcaster, we'll let Brian tell us a little bit about himself, and we'll take things from there. So Brian, I'm going to pass it over to you.
Okay. Well, my name is Brian Barnett. I've been in my 35th year as a civil structural engineer. I'm kind of impressed by the generation coming into our industry these days, because they were in high school and they seemed to have a very good idea of what they wanted to do when they got out, went to engineering school. When I was in high school, I took a very different approach. I went to a welding school, became a welder, successful welder, enjoyed it very much. One day, a coworker of mine said, "Hey, you're a pretty sharp guy. You ought to think about going to civil engineering school." And so I looked into it, enrolled at the University of Texas in Austin, was accepted. And after graduation, joined TxDOT. Was my first job working with bridges. So that was a lot of fun.
How long did you do that?
I was there for close to 7.5 years.
Okay.
And it was very interesting in that, I did some design work, but it was one of the main roles I played was to coordinate the state's inspection program for bridges. Mm-hmm. And so I was exposed to not only the modern types of bridges that you see every day when you drive down the road, but all the historic stuff that's no longer in vogue. Truss bridges that were built out of kits back in the 1800s, things of that nature. Do a lot of structural analysis of a large variety of materials and configurations. So that gave me a good starting place, a good background to move on.
And how many different positions have you held over your career so from TxDOT till today?
So from TxDOT, I went to a marine engineering company. I then went to a general civil engineering firm. I then went to an electric utility, which is how I got started in what I do today. So out of the nearly 35 years I've been practicing, I've been doing the electric utility side of it for 18 plus years.
So I've got a question for you. I've not asked anybody else so far. 35 years, long time to have a career. Talk a little bit about technology and how it's evolved. And when I say that, I'm gonna ask you from two perspectives. So let's talk 35 years from one, and then from another. Technology that you actually used to do your engineering work. So I suspect that when you started, you were slide rule guy.
I was exposed to that and punch cards.
Punch card, okay. So I'm
did.
going to have to put up a little display for everybody. We'll cut away and I'll bring up a little image of what a punch card is for people. But
I'll describe it briefly.
okay, go ahead.
Back in the day, we didn't have personal computers. We had large mainframe computers that would fill up large rooms or small warehouses. We would access those through a monitor called a cathode ray tube. It was a very large monitor. That was kind of later, but when I first started, we were using punch cards. You would use a device that was much like a typewriter, and it would punch little holes in these rectangular cards, and you would hand this stack of sometimes hundreds of cards to a person who would feed those into a reader, and that would be your programming. The computer would take your program and run it, and the next day you'd come back and they'd have a big stack of paper to hand you with your results.
Right. And the key thing there is the next day.
Right.
It was no immediate response, right?
No, and so, with that, especially being, young, new engineers, you're sometimes made mistakes. So you come back to a large stack of paper and an angry person who just counts the number of micro minutes, that a mainframe computer used to run your program to no avail. So they were very dissatisfied at you.
Right.
Well, then you get to fix the problem and run it again and come back the next day for the result.
So that was the first experience with computer programming.
It was.
Yep. It
was.
So talk about the other tools that you have seen come along the way through your career.
Well, interestingly, a lot of the programs we used to do analyses were of course mainframe based, and what that meant was when you were inputting data, whether it be a beam size or a span or a section property, you had to enter these values in specific rows and columns delineated by commas or spaces at the proper locations. An example of what would happen if that wasn't done correctly, if you entered a 1 and the decimal place was in the wrong place and the computer thought you meant 1,000, then your results were pretty severely off. So that was very, very detail oriented.
So a lot different than today, where you would have an interface and would say, enter the number of beams, and you type in 3, and then enter the spans, and you go, like 100, 150, 100 or something like that. In the old days, you would just type down, on these cards, the 3, 100, 150, and there was no user interface, right? I mean, there wasn't anything to help you. You had to have almost like a little manual to say, this is the data that you need to enter and how you need to enter it. And so another word that students may not be familiar with that much is syntax.
Yeah.
Syntax was a 4-letter word, right? And when it came to programming.
It was. So, fast forward, I think it was 1995. I was at a consulting firm, and we went to a country club one night to an ASCE meeting, American Society of Civil Engineers, to listen to someone speak about the World Wide Web. We knew nothing about it, didn't know what that was, and we listened to this person go through what it meant, how it was going to be developed. He tried doing some demonstrations on a dial-up line, with poor result. Right. And I think we left, most of us, thinking this will never work. Why are we talking about this?
All right, here we are today talking at a distance, and another thing I'm sure you probably remember that falls under sort of the same category is transferring anything other than text. It was easy to send text, but images could take a long time. Simple images would take a long time to show up at the other end, and the idea that you would ever have video, No, and little by little, here we are today. So,
Right.
I mean, you really have experienced a very, dramatic shift in the way that we operated in terms of doing the work of engineering. Because I guess I would say for you, calculator, mainframe kind of computer at the front end, and now I'm sure that whatever the software is you guys have, but now
Right.
you're running high end. It's you got a user interface that's asking you everything that you need to enter, and making sure that that everything you're entering makes sense, and checking your input before it ever even starts the processing, which takes milliseconds to do a multi-story building.
Yeah, it does. And, a lot of the software now, as you say, it's immediate gratification. Some of the software available even tells you if there's suspect entries before you run it. And if you run even a large structure with lots of components, it can happen in a matter of seconds versus overnight.
So talk a little bit about the technology of civil engineering, and not so much that there's a software package that you use, but when I and I'm sort of fascinated. I have purchased old volumes of like the AISC steel code and the ACI code back when I've got a copy of the ACI code that's about almost like a 4x6 index card in size, and today it's an 8.5 by 11 size, and it's an inch thick or something like that. So the engineering technology has really evolved. Can you talk tell us a little bit about your career and how that side of things has changed?
Well, in some respects, it's remained the same. You go through an engineering career, and there's no way you will ever be able to avoid doing hand calculations. It's just an everyday tool you use, whether it's in a meeting and you need a quick back of the envelope type of answer, or a detail analysis where this may be the one time you do that analysis, and you're just not going to invest in expensive software to do it for you. So a lot of the theory is the same, and the calculations are very similar. The thing we see changing is the technology and the information that comes from research, which is constantly ongoing, as I'm sure you're very aware of and involved in. The research gives us more empirical data to work from, things that have been tested in a laboratory, so we can oftentimes use that empirical data or formulas that come from that, as opposed to the theory, to do analyses and get a much more realistic result in many cases.
Right. So even though the software is generating some output and telling you whatever that particular software is telling you, what I'm hearing and what I would tell students is you don't just blindly accept it, correct?
You don't. And one of the things people, I guess, with our experience bring to the table is the ability to have made all those mistakes and seen the results so many times that one of my main roles is doing a quality assurance, quality control, and so I see a lot of stuff come across my desk to review and make sure it's correct. And I can pretty quickly look at something and tell when something's not quite right, and then I just have to dig in and find out why.
Right. Because there are going to be the unusual circumstances for one reason or another. So
you really had to, before you run that sophisticated software, it really helps to kind of know what the answer is going to be before you do.
Yeah, the software is just confirming it for us.
Exactly.
Right.
And And the other thing I would add is since I started, there's a much higher standard of care from I would say most organizations and clients to prove it up with the most sophisticated softwares and tools versus I've seen that before. That's the correct answer or whatnot.
Mm-hmm. So as you've worked at places and they've brought either had, let's kind of step back to software. They either have a software package or purchased one while you were working. How did you learn to, operate that software? Was that everybody was just expected to figure this out on their own time? Would there be somebody in the office that would become the guru for the software package and help everybody? I mean, how as the technology advanced, how did you advance with it so that you could utilize it?
That's a great question. I'm not sure I have the perfect answer, but I can say that what I've observed is everyone's kind of thrown in there saying, here's this new software tool, dig into it and let's see how it works. And there always seems to be one or more people that kind of quickly pick it up and run with it, and then they become that go-to person.
Right. And yeah, because somebody has to make sure that they know what they're doing. So tell us a little bit about what you're doing today. So you mentioned you're doing a lot of review stuff, but maybe project-wise, what kind of projects are you involved in today?
Well, the company I work for, Pickett,
yeah.
Pickett and Associates is a company that does surveying and mapping, but on the engineering side, we focus more on the transmission lines and high voltage substations. And this will probably be what confuses most people. It's thought to be a highly electrical engineering oriented field. However, the design of transmission lines and substations is a very huge component of that is civil structural work.
Yeah.
And so the industry is always trying to attract civil structural types and has a hard time doing so because most students don't even realize or think to look into that field. They think, well, that's electrical. That's probably not something I'd be geared up for.
Sure.
So, we may do a transmission line that's a mile long or a transmission line that's hundreds of miles long with hundreds of different structure types. They may be poles, they may be big steel lattice towers or varieties of both.
Sure. One of the things that our civil engineering program is very interested in is the use of technology to monitor and manage infrastructure assets. So are in the work that you're doing, are you incorporating any sort of sensing devices, or is that not part of the work that the portion of the projects that you're involved in? But are you seeing this in the power field? A lot of this smart grid conversation and construction that's going on. Are you able to comment at all on sensing devices?
Some, having worked at a utility for a long time, that's quite fascinating, really. For example, there can be an outage due to a fault on a transmission line somewhere between point A and point B, and it may be 100 miles apart, those 2 points. And they can tell you within usually a matter of feet where that fault took place just by the relay systems involved in it. And at the utility I work for, there was a big series of electronic data being on the wall, where they were looking at our electric grid in real time, figuring out, what was going, what amount of electricity was going from point A to point B through every segment of it. And, I distinctly remember occasions when there was a mishap that caused structural damage to some of the towers because of something that ran into a transmission line. And they were able to tell me exactly where to go on the map to find that problem. in the, before this technology, I would have been driving 100 miles through hard terrain trying to find it.
Just looking for the evidence of the damage. That fascinating. So I guess I would assume that the power industry is very into drones.
It's come a long ways, in the past, 10, 20 years, especially the last 10 years. I've seen organizations developing within their survey and mapping units drone technology, and other people will become pilots so that they can properly operate and follow all the federal guidelines.
Yeah, yeah. I was just thinking about following a transmission line, getting up above it and helping you to spot those locations of where you need to intervene. So
yeah, and it's getting better and better. With all technology, they're able to fly lines and fly up to a tower now. And I remember an occasion where I asked some of our drone pilots at the utility to fly up there and get real close to this part of a tower. I needed to see if there was some bolts missing or what was going on, because there was some bent or damaged members.
right.
They were able to do that effectively.
Yeah. So that's very cool, because what would be the alternative? You have to send somebody up either in a lift truck or climb a tower, I would guess.
Which ordinarily means taking the line out of service, which is
Right.
frowned upon these days.
Yeah.
The lines seem to be at capacity all the time.
Yeah. What, tell us a little bit about, 35-year career, you've had to have seen a lot of interesting things. So can you think back to some project that you were involved that, just was, wow, this was such a cool day, I'm glad I do what I do, kind of a project?
Yeah, there's been a lot of those things I'm fairly proud to have been involved in, and looking back on them, they seem more interesting now almost than they did then. But, I guess one thing I'll reflect back to is roughly 10 years ago, I received a phone call that a tower, a transmission structure had failed and gone down. That was all I was told. It had gone down, meet us here. So I reached the site, and it was a line we had under construction. And a big pole called a dead end, and called a dead end because it is designed to handle the full tension of large electric wires pulling on one side of it.
Yeah.
So unbalanced loading conditions.
Sure.
So it had fallen over on the ground, and the pole had ripped off of a thick plate of steel called a base plate that is bolted down to a foundation. So I then led an investigative effort. We brought in experts doing metallurgical testing and so on and so forth. So I was involved in that investigation over the course of 2 years to determine the cause of that failure. Fortunately, the crews had strung wire on one side of that pole, and they had gone home for Thanksgiving holidays, because if it had fallen while crew had been on site, there would have been injuries or worse. It turned out to be a manufacturing defect, cracks that had developed as part of the welding process. Lots of chemical elements in the steel, things that you recognize as problems now that I won't go into here, but it was a metallurgical issue with the fabrication process that caused the failure.
Interesting. Something that kind of popped in my head as you were talking about that is, we have discussions and we talk with students about, like, who owns infrastructure, who decides infrastructure is going to be needed and built, and then where is it going to go, who owns it, who maintains it, who pays the bills on it, and those sorts of things. So let me ask you a little bit, who owns that tower? So this tower, collapses. So now somebody's got to pay for it to be repaired, you know, to get service back. But then there are legal bills, issues, and those sorts of things. So give us a little insight into the you know, powered sector of our economy, and who owns these things. I mean,
Okay.
who owns these electrons that are moving down this wire, you know, to somebody's home.
So you have electric generators. These are the people that produce the electricity. Then you have the transmission and folks and the transformation folks. So you take electricity at a certain level out of a power source, a power plant, and you do what you want to do with it with a transformer. You raise the voltage, send it long distances through a transmission line, and you get it to a substation where there is a need for it. Maybe it's a factory, maybe it's a city with subdivisions that need electricity. And then it's distributed through a lighter voltage, a lower voltage system to those needs. So who owns all of those facilities? There are electric utilities, large electric utilities that own large transmission facilities. You know, there's some in locally. Lower Colorado River Authority owns a lot of the transmission lines that, as you're driving around, you see in central Texas. If you know, there's other utilities in Texas. They own a lot of these facilities. They own the wire. They own the poles and the towers. They own the easements that build these things on, because you have to get permission from landowners and pay them for the right to build these lines, and that's called an easement when you pay for that right.
And to get access.
To get access, correct. And sometimes city municipalities own some of these facilities. So it's very often, you know, utilities, whether it be at a local level or a larger statewide level in Texas. And I say in Texas because Texas largely has its own electric grid. It's not connected to all the surrounding states. Other states, you know, when you hear of outages where you have blackouts that affect several states, many of these states share an electric grid. We are fairly unique here in that we largely do not. So how these things get built, there's usually electric studies done that develop a need. They'll show that if we don't build a transmission line within this corridor, this city or this part of Texas is going to have an electric need shortfall by the year 2025. There's a public utility commission in Texas that regulates the industry, and they also do studies. And sometimes they come to the utilities and say, we need a transmission line, or there's going to be a shortfall within this corridor. So it's kind of a two-way street in working with the state agencies and the utilities. So then the utility will build this project, and the way it gets funded is the utility, after it's available for use, will go to a public utility commission, and they'll file in a rate case sometimes. Sometimes they'll file what's called an interim capital addition, which basically these are both ways of saying, look, we spent $10 million to build this line, put it in the rate base, and so whenever you get your electric bill, it will be folded into what you pay for these facilities, and it's over a statewide basis.
Sure.
So just because this transmission line serves San Marcos doesn't, you know, somebody in Amarillo may be helping to pay for that transmission line.
Okay.
and vice versa.
Right. So if something, so real quick, because we're coming near the end of our time, but you can have somebody own the power generator, somebody else own the tower, somebody else own the line, the transmission lines. It could be the same, but the possibility is that those are all different owners. The substation, a different owner. That if you are actually wanting to be a power generator, you would end up having to deal with different people in order to move your power from point A to point B. So it's actually probably in the better interest of the power generator to own as much of that system as they can. Would that be a fair statement, so that they can sort of control the whole operation?
It's not quite that simple. There's when in Texas a deregulation law was passed so that they separated the generators from the transmission side. So there's certain amounts of information they're not even allowed to share with each other. So it creates unfair market advantage.
Gotcha.
But it is regulated at the statewide level. There are people that look at where electricity is needed, and they'll look at it in real time, who is generating the cheapest electricity that day. And so they will try to route that cheapest electricity to that point of need.
Mm.
So that's how it's determined whose transmission lines it goes through. And then the utility that owns the transmission lines gets paid for the transformation
usage. Well, it sounds to me like we're going to have a follow-up conversation to learn about power and power grids and that side of things. So it's as us in the structures world, and I'm sure in others, it's the invisible engineering, because you can't grab a hold. I mean, if you grab a hold of the wires and the towers, that's structures, but I'm not grabbing hold of electricity anywhere. So,
right.
So I'm sure you've heard that before. So, well, this has been excellent. It's a topic that we haven't had, that we have not discussed before in the podcast. So it'll be a nice addition. But yeah, I would like to get back in touch with you and have another conversation just about actually how do we get power from point A to my house, that we're able to have this conversation right now. I think would be an interesting conversation to have. So enjoyed this tremendously. I hope you had a good time on Let's Be Civil podcast, and I look forward to talking to you again sometime soon here.
Well, thanks. I enjoyed it too.
Yep.
Appreciate it.
Okay. We'll see you later.
Okay.
Have a good day.
Bye-bye now.
Bye.